Welcome to the Arithmetic Zone, and today we're going to introduce the concept of integration by parts. So, what is integration by parts? It's a special integration method used to solve complex integrals where standard integration and u sub do not apply. For simple integrals, usually you would just use the many different integration rules and or any u sub if necessary. Integration by parts is used when you encounter two separate functions within one integrand and those rules do not apply. You can think of integration by parts as undoing the product rule. So if you look at this formula right here, if you have an integrand of a function and the derivative of another function, so u is one function and v is the other function, then to find the integral, it's equal to uv minus the integral of v du. Now, which function becomes u and which function becomes v is very important. Good way to remember what to do when deciding which one becomes u and which one becomes v is to remember the acronym LIATE, which doesn't really mean anything, but it's definitely an easy made-up word to remember. So LIATE stands for logarithmic, inverse trig, algebraic, trigonometry, and exponentials. And essentially, as you go down LIATE, whichever function appears first in your integrand, so let's say one of the functions in your integrand is a log function and the other one is a trig function. Whichever one comes first, so a log, that one becomes u, and then the other one, which is trig, becomes v. So to see this all in action, let's look at our first example, where we have the integral of x e to the power of x dx, and I rated this as an easy problem. This is a pretty straightforward and simple question that requires IBP. So first step is to determine which between our two functions is u and which one is v. So let's pull up the LIATE acronym right here to the right. Now, what are our two functions? We have an x and we have an e to the power of x within our integrand. These two functions are completely unrelated. You can't, take the integral of e to the x and somehow just get regular x from it in any way. So we're going to have to use IBP. Now, looking at our x and e to the power of x, and as we go down this list, which one comes first? Well, x is an algebraic and e to the power of x is an exponential. Algebraic comes first, so x becomes u, so u equals x. And e to the power of x, it does not become v, it actually becomes the derivative of v, dv. So that becomes e to the power of x dx. Now, once you find u and v, what you want to do is find their corresponding derivative or antiderivative. So for dv, its antiderivative v, that would just be e to the power of x. And for x, the derivative of u, du is just 1. So once you find these values, you take the formula. If you don't remember it, it was uv minus the integral of v du. And you put the values you found accordingly. So when everything is done, that would be x e to the power of x minus the integral of ex dx. Obviously, we're not done here, as we still have another integration stage to do, integral of e to the power of x, which is very simple. It's just e to the power of x. So our final answer turns out to be x e to the power of x minus e to the power of x plus c. And if you notice, you may realize that the acronym LIATE purposely orders all these different types of functions in a way so that the easiest function to integrate is at the end. So exponentials are the easiest to integrate, hence they're at the end. Logarithmic functions are the hardest to integrate because you actually cannot integrate those under standard methods, hence they're at the top and they pretty much always become u. Now let's look at our next example. X times sine of x dx. So again, let's pull up our LIATE chart. If you don't remember what each letter stands for, don't worry, I do got you. But anyway, let's look at our two functions. We have x and sine of x. X is an algebraic function, which is a. Sine of x is a trigonometry function, which is t. So in this case, the algebraic function comes first, just like last time. So x is going to become u, and hence du is 1. As for the second function, sine of x, dv is sine of x dx, and v is the integral of sine of x, which is negative cosine of x. And I should probably write the dx here as well. Wrong color, but you guys know what it means. So again, we take the expression uv minus the integral of v du, and what we get is x times negative cosine of x minus the integral of negative cosine of x dx. Now let's rewrite that in a more tangible manner. So we have negative x cosine of x plus the integral of cosine of x dx. Why? Because these two negatives can cancel out, because you can just bring this negative outside, because this is just negative 1 if you think about it. So we got to take another integral right here, cosine of x dx, and what we're left with at the very end is negative x cosine of x plus sine of x plus c. So up until now, we've only been doing easy problems as noted in the top right. So let's pick it up a bit and go to our first medium problem. We have the integral of ln of x dx, but not just an indefinite integral. We have a definite integral from the bounds between 1 and 2. So I think the first step is to just pretend that this is an indefinite integral, as it'll make our lives slightly easier. So I just rewrote it as the integral of ln of x dx, and I wrote it in this manner because I want to emphasize the fact that when you look at this, ln of x is technically just one function. So how could I use integration by parts if I don't have two functions in my integrand? Well, this is equal to ln of x times 1, and 1 is going to be our second function. So again, we're going to use the concept of Lyautey. So let me pull up the chart again, and we have our functions ln of x and 1. So 1 is an algebraic function, and ln of x is a logarithmic function. So this time the algebraic function does not come first, the logarithmic does. So we're going to make u ln of x, and the derivative of ln of x is just 1 over x. I'm just going to write it as x negative 1 dx. And then for our v's, dv is 1 dx, and v is not the derivative, the antiderivative, which is just x. So again, we're going to write this in the form of uv minus the integral of v du, and that turns out to be x ln of x minus the integral of 1 dx. So again, we're going to take the integral. Again, integral of 1 is just x, so we're left with x ln of x minus x plus c. But remember, in the beginning of the problem, we had this definite integral, so we were treating this problem as if it was an indefinite integral the whole time. Now we got to actually use the fundamental theorem of calculus to find the definite area. So we're going to get rid of the plus c, and we're going to put in the bracket for 2 to 1 to indicate that we're going to use ftc to find this value. So I'm going to move on to the right side and sub in the 2 and the 1. We have 2 ln of 2 minus 1 ln of 1 minus 1. Keep in mind that this minus sign right here is distributed to this whole expression right here. And also ln of 1, if you remember, is just equal to 0. So 1 times 0 is just 0. So this really just becomes 0 minus 1, which just becomes negative 1 in that whole red parentheses. So we can rewrite it as 2 ln of 2 minus 2 plus 1, because we're negating that minus 1 at the end to get plus 1. So again, we can simplify and have 2 ln of 2 minus 1 as our final answer for this example. You could also rewrite it as ln of 4 minus 1, because if you know your natural log properties, 2 ln of 2, you can rewrite this as ln 2 to the power of 2, because any coefficient of a natural log, you can turn it into an exponent to the value inside, hence it becomes ln of 4. So you can write the answer as 2 ln of 2 minus 1 or ln of 4 minus 1. Both are perfectly acceptable. So what's up next for integration by parts? Well, we're going to look at harder examples of IBP, ones that require multiple stages of integration by parts, and ones that require different types of functions, as you see in Liate, and even an example where you may encounter an infinite loop. See you next time.